Somewhere in Spartanburg, South Carolina, a factory worker shows up every morning at 6. He has been doing the same job for 11 years. He loads sheet metal parts into a welding fixture, hundreds of times a day. Same motion, same weight, same angle. In 2025, his employer ran an experiment on the line next to his. The experiment worked. And now the calculation that every plant manager in the world is quietly running has a number attached to it. $2 per hour. That is the projected operating cost of a humanoid robot at scale, according to a study released by Roland Berger in April 2026. Not the purchase price, the cost to run one. Per hour, $2. The average fully loaded manufacturing worker in the United States costs over $150,000 per year. That is roughly $72 per hour. When you factor in benefits, insurance, sick days, and turnover. $2 versus $72. Most people, when they hear about robots in factories, think, someday. Pilot programs, years away, still too expensive, still not capable enough. What the data from 2025 and 2026 actually shows is something different. The tipping point that economists have been modeling for a decade has a location. It has company names attached to it. It has shift schedules. It is not coming. For high-wage markets, it is already here. The story most people have heard goes like this. Robots are getting better. Automation is coming for jobs. And somewhere in the future, things will look different. It is a story told in the future tense, always arriving, never here. The layer underneath that story tells a different timeline. In 2025, a company called Figure deployed 2 humanoid robots at the BMW manufacturing plant in Spartanburg, South Carolina. Not in a lab, not in a demonstration. On the actual production line, running 10-hour shifts, 5 days a week. Over 11 months, those 2 robots loaded more than 90,000 sheet metal parts. They contributed to the production of over 30,000 BMW X3 vehicles. They walked a combined distance of over 200 miles across the factory floor. BMW then expanded the program to Leipzig, Germany. The same model, now moving to Europe. On February 19, 2026, Toyota Motor Manufacturing Canada signed a commercial agreement with Agility Robotics. Not a pilot, a commercial agreement. 7-digit robots deployed at the Woodstock, Ontario facility, where RAV4 sports utility vehicles are built. The agreement followed a year-long evaluation. Toyota had looked at multiple robots and chose this one. In May 2026, Japan Airlines launched a 2-year humanoid robot trial at Haneda Airport in Tokyo. Baggage handling, cargo transport, ground operations. The robots are 132 centimeters tall, designed specifically to fit inside aircraft spaces without requiring any changes to existing infrastructure. 3 industries, 3 continents, the same pattern, the operating threshold, the specific moment when a robot becomes cheaper to run than the human doing the same job, has already been crossed in high-wage manufacturing environments. The question is no longer whether this happens. The question is how fast it spreads. In the 1820s, the handloom weavers of northern England were among the most skilled workers in the world. They had spent years mastering their craft. They produced high-quality cloth that sold across Europe, and they had good reason to believe their skills protected them. The power loom had existed for decades by then. Edmund Cartwright had patented the first version in 1785. But for a long time, it was unreliable, expensive to maintain, and produced lower quality fabric than a skilled weaver could manage by hand. Then, 2 things happened simultaneously. The machines got better, and the math changed. The operating threshold for the power loom shifted, not because of one breakthrough, but because of the accumulation of small improvements across materials, mechanics, and management. At a certain point, the calculation that mill owners had been running for 20 years produced a different answer. And within a decade, the number of handloom weavers in Britain collapsed from 240,000 to under 50,000. The weavers who got it wrong shared one belief, that the complexity of their work was a permanent barrier, that what they did required human judgment that machines could not replicate. They were right about the complexity. They were wrong about the permanence. The operating threshold crossed quietly. By the time most weavers understood what had happened, the mill owners had already made their decisions. Roland Berger released its study, Humanoid Robots 2026, The Convergence Moment for a New Market, in April 2026. The headline number is $2 per hour in operating costs at scale. That figure includes energy, software licensing, network connectivity, scheduled maintenance and depreciation. IDTechEx, the independent market research firm, projects operating costs below $5 per hour by 2030 across a broader range of deployment conditions. Even at $5, the gap against a $30 per hour warehouse worker is structural. It does not close. Agility Robotics targets a return on investment of under 2 years when compared against a $30 per hour warehouse worker. At current pricing, before costs fall further, Unitree Robotics, the Chinese manufacturer whose robots Japan Airlines is now using at Haneda Airport, shipped over 5,500 units in 2025 alone. The base price of their G1 model is $13,500. For context, a single United States manufacturing worker costs an employer more than that in salary alone every 6 to 8 weeks. The operating threshold is not a single number. It is a calculation that looks different in every sector, every country, every wage and environment. In Germany, the United States, and Japan, where wages are high and labor markets are tight, the calculation is already producing the answer that BMW, Toyota, and Japan Airlines have started acting on. Roland Berger projects the total humanoid robotics market could reach $4 trillion in the long term. Thomas Kirschstein, a partner at Roland Berger, said in April that we are currently at the point where technological feasibility is meeting economic necessity. Here is the dimension that even well-informed people tend to miss. The jobs that humanoid robots are being deployed into first are not the jobs that most people think of as vulnerable. They are not the knowledge worker roles, the creative roles, the management roles. They are the jobs that nobody wants. At Toyota Canada, the robots are unloading totes of auto parts from automated tuggers and feeding them into the production line. It is physically demanding, repetitive, and one of the roles with the highest turnover in the facility. Tim Hollander, the president of Toyota Motor Manufacturing Canada, said the goal is to free workers from the most demanding physical tasks. At Haneda Airport, Japan Airlines is deploying robots specifically because Japan faces a structural labor shortage driven by an aging population. There are not enough people willing to do baggage handling. The robots are not replacing a workforce that wants to stay. They are filling a gap that already exists. This is the pattern that makes the operating threshold so difficult to resist. The first wave of humanoid robot deployment is not arriving as replacement. It is arriving as a solution to labor shortages, to physically dangerous conditions, to the jobs that are hardest to fill. By the time the second wave arrives, the infrastructure will already be built. The operating threshold will have moved again, and the jobs that seemed safe in the first wave will face a calculation that looks very different from the one that exists today. The handloom weavers did not lose to a better machine. They lost to a cheaper calculation. In the 12 months since the BMW Spartanburg deployment became public, something shifted in how the largest manufacturing companies in the world are structuring their decisions. GXO Logistics, the world's largest pure-play contract logistics provider, moved beyond pilot agreements with Agility Robotics into active commercial deployment before Toyota Canada signed its contract. Amazon has humanoid robot programs running across multiple fulfillment centers. Schaeffler, the German automotive supplier, is in active deployment. The pattern in how these companies are moving is instructive. They are not waiting for the technology to be perfect. They are not waiting for costs to fall further. They are deploying now, at current pricing, in specific high-turnover roles and building the internal expertise that will determine how fast they can scale when costs fall further. The signal is not in the headlines about humanoid robots. The signal is in the procurement decisions that are not making headlines at all. If you want to keep seeing the next layer before it becomes obvious, this is where that happens. Every week, before the mainstream catches up. That factory worker in Spartanburg still shows up every morning, but the line next to his has changed, and the calculation his employer is running has a number attached to it, now that it did not have 2 years ago. $2 per hour is not a prediction. It is not a warning from a think tank about what might happen someday. It is a figure from a strategy consultancy describing what is already technically achievable in April 2026, based on systems that are already running in factories and airports across 3 continents. The operating threshold was always going to arrive. The economists modeled it. The technologists built toward it. The only question was timing. What the deployments of 2025 and 2026 show is that the timing question has been answered. The next layer was always there. Now you can see it.